Tonight, we are going to explore the chilling physical law that forbids the universe from ever truly deleting you. There is a moment just before you fall asleep when a thought completes itself and dissolves. The idea was there. It formed somewhere behind your eyes, took shape, had weight and color, and the particular texture of whatever you were thinking about. Then it was gone. You lost it the way you always lose thoughts at the edge of sleep, without ceremony, without a record.
Except that is not what actually happened. What actually happened is physics, not metaphor, not poetry, literal, measurable, testable physics that one of the most careful information theorists of the 20th century calculated down to the last joule, and that has been confirmed experimentally more times than most people will ever know about. When that thought dissolved, something left your brain that did not vanish. It could not vanish. The laws of physics do not permit the kind of vanishing that the word suggests. What happened instead is that the information your thought was made of, the specific configuration of neural states, the particular pattern of electrochemical signals that constituted that specific thought, at that specific moment, that information moved. It transferred. It dispersed into the thermal environment around your head. It became heat.
Not metaphorically. Literally, the dissolution of a thought produces heat. Rolf Landauer showed this in 1961 in a paper that almost nobody read at the time, and that took decades to be recognized as one of the foundational results of physical information theory. The paper was called Irreversibility and Heat Generation in the Computing Process, and it said something that sounds, on first encounter, like philosophy dressed in equations, but is in fact one of the cleanest pieces of physics published in the second half of the 20th century.
Landauer's principle says this: erasing one bit of information, one binary digit, one yes or no, one on or off, releases a minimum amount of energy into the surrounding environment. The minimum is precisely calculable. It is the product of Boltzmann's constant, the ambient temperature, and the natural logarithm of 2. At room temperature, this works out to approximately 3 times 10 to the power of negative 21 joules per bit erased. A number so small that it seems trivial. But it is not trivial. It is one of the most profound things physics has ever said, because of what it implies about the relationship between information and the physical world. It implies they are the same thing. Not analogous, not parallel, the same. Information is physical. Physical systems are informational. There is no gap between them, no category error waiting to be corrected, no level at which one describes a more fundamental reality than the other. When you erase information, you release energy, and that fact is not an accident of how computers work or how brains are built. It is a consequence of the deepest laws governing how the universe is organized. Your thought produced heat when it dissolved. A measurable, in principle detectable quantity of heat. Not because something went wrong, not because the process was inefficient, but because the erasure of information is, by physical law, a thermodynamic event. It has a temperature. It has an entropy signature. It is, in the most precise sense available to us, real. Think about what this means for the most ordinary moments of your mental life.
You change your mind about something. You decide one option is better than another, and you let go of the alternative. The information about the path not taken, the neural representation of the option you rejected, is in some sense erased. It doesn't occupy your working memory anymore. You've moved on. But that erasure had a cost. A tiny, completely imperceptible, but physically real cost paid in heat. The bit of information about the rejected option joined the thermal bath of your body, dispersed as molecular kinetic energy into the fluid around your neurons, became an infinitesimal contribution to your body heat, radiated outward as infrared into the room, and eventually propagated as photons into the environment around you.
The thought you abandoned left the room. As heat, this is not a metaphor for the way decisions feel. This is not a poet's description of letting something go. This is thermodynamics. This is the second law of thermodynamics, applied to cognition. And it means something extraordinary. It means that thinking is a physical event in the most complete sense. Not just that thoughts require a physical substrate, we knew that, in a rough way, for a long time, but that thoughts participate in the physical economy of the universe in exactly the way that all other physical processes do. That a decision made in silence in a room, with no external action taken, nevertheless changes the physical state of the universe in a precisely calculable way. The universe knows you thought that thought, not metaphorically, thermodynamically. Before we go further, I want to say something directly to whoever is listening to this tonight. If you found this channel, and you are here at this hour, thinking about things like the heat of thoughts and the physics of information, you are probably someone who moves through the world with a specific kind of restlessness. The kind that comes from knowing, at some level you cannot always articulate, that the ordinary explanations are not quite complete. That the world is deeper and stranger and more specific than the way it is usually described. If that is you, this channel exists for you. If the ideas here find something real in you, a subscription helps the algorithm find more people like you, more seekers, more minds that understand that reality is deeper than what we see. That is all. Now let us keep going. Landauer published his result in 1961. It sat largely unnoticed for about 2 decades. The physics community was not, at the time, thinking of information as a physical quantity. Information theory was considered a branch of mathematics or engineering, not fundamental physics. The connection between information and thermodynamics was considered a curiosity, a formal analogy, not a deep physical truth. Bennett showed that any computation can, in principle, be performed reversibly. You can rearrange the logic of any computation so that no information is ever destroyed during the computation itself. Every step is reversible, every intermediate result is kept, and the final answer is obtained without any erasure until the very end, when you choose to clear the scratch work. This reversible computation produces no heat, zero. The heat is paid only when you erase, and you can, in principle, delay erasure or eliminate it entirely. The practical implication is that conventional computers are enormously wasteful of energy, not because computation requires energy, but because conventional computers erase information constantly, billions of times per second, without thinking about it. Every time a logic gate resets, information is erased and heat is released. Modern processor chips get hot, not because moving electrons takes energy, but because erasing bits takes energy. And modern processors erase bits constantly. In principle, a perfectly reversible computer would generate no heat at all. But that in-principle reversibility points to something deeper than computer design. It points to the universe. If computation can be made reversible, and if the universe is, at its fundamental level, a computation of some kind, a process that evolves one physical state into another according to fixed rules, then the universe might itself be a reversible computation, a process that never erases, that takes in quantum states and outputs quantum states without any loss of information. The laws of quantum mechanics, as it happens, say exactly this. Quantum mechanics is reversible at the fundamental level. The equation governing quantum evolution, the Schrödinger equation, is time reversible. It describes the quantum state of a system as a function of time, and the function can be run either forward or backward. The information in the initial quantum state is exactly preserved in the final quantum state. No information is created. No information is destroyed. Not into the fire itself. The flame is not a repository of the match's molecular blueprint. Not into the ash. The ash has far less information about the original structure than the original structure had. Not into the gases. The distribution of gas molecules in the room around the burnt match contains nothing that looks like the original information. And yet, the no-hiding theorem, a theorem proved by Samuel Bronstein and Arun Patti in 2007, says that the information did not vanish. It is hidden, specifically and provably hidden, in the quantum correlations between the products of the combustion and the environment. The no-hiding theorem is one of the least known and most important results in all of physics. Almost nobody outside the quantum information community has heard of it. The theorem deserves more attention than it gets. What it says is this: if a quantum system loses information, if the quantum state of a system becomes mixed, becomes less pure, becomes scrambled, that information must go somewhere. It cannot simply cease to exist. And the somewhere is not arbitrary. The information does not split up and go partially here and partially there. It does not stay associated with the original system in a hidden way. It goes into the global correlations of the environment. The correlations between all the environmental degrees of freedom that interacted with the system. And once there, it cannot be recovered by any local measurement of any piece of the environment. It can only be recovered by a global measurement of the entire environment simultaneously. This is a mathematical theorem. It has been proved. It follows from the axioms of quantum mechanics, and it has a consequence that is almost shocking in its directness. The environment is a library. This is called unitarity. It is one of the most sacred principles of quantum mechanics, and it says, in the clearest possible terms, that the universe does not erase. The universe never erases. Every quantum state that has ever existed in this cosmos is, in principle, encoded in the current quantum state of the cosmos. The equations of quantum mechanics, applied to the universe as a whole, say that you can run the evolution backward and recover every prior state. Not just the state a moment ago, every state. All the way back to whatever the universe was before it was anything recognizable. This is the bedrock on which everything else we discuss tonight stands. The universe is a reversible system. Reversible means information conserving. Information conserving means nothing is ever truly erased. Nothing that has ever happened is gone from the universe in the fundamental physical sense. Everything that has ever happened is still in the universe, encoded, scrambled, distributed, inaccessible, but there. Now, let us understand precisely what happens to information that seems to disappear. You light a match. The wood burns. The organized molecular structure of the cellulose fibers in the matchstick, their specific chemical bonds, their precise spatial arrangement, the quantum states of every atom in the wood is destroyed by the combustion. What was an organized, low-entropy structure becomes gases and ash and heat. The structure is gone. The information about that structure seems gone. Where did it go? The quantum state of the universe's environment, the thermal bath, the electromagnetic field, the molecular medium through which all interactions propagate, is a library in which every quantum event that has ever occurred is recorded. Not in a legible form, not in a form that can be read out, but in the global pattern of quantum correlations, the vast web of entanglement that connects every particle that has ever interacted with every other particle. Every photon that has ever been absorbed by the atmosphere carries its information into the quantum correlations of the atmosphere. Every molecule that has ever collided with another carries information about that collision into the correlations of whatever medium surrounds it. Every quantum state that has ever mixed with its environment has left its information in the entanglement structure of that environment. The environment does not remember in the sense that we remember. It does not have a retrieval system. There is no index,
no search function, no way to look up a specific event and recover its information. But in the mathematical sense of information, the precise, quantitative, Shannon information sense, the information is there, preserved, present, as real as any other physical quantity. Think about the room you are in right now. Every conversation ever held in that room. Every breath exhaled by every person who has ever occupied that space. Every photon emitted by every source of light that has ever illuminated it. Every sound wave that has ever propagated through its air. All of it has left traces. Quantum informational traces in the state of the matter that fills and bounds the room. Not memories, not ghosts, physical correlations. Quantum entanglements between molecules that carry, in their pattern of correlations, information about every event that has ever disturbed them. The room is an archive. The universe is an archive.
Not into the fire itself. The flame is not a repository of the match's molecular blueprint. Not into the ash has far less information about the original structure than the original structure had. Not into the gases. The distribution of gas molecules in the room, around the burnt match, contains nothing that looks like the original information. And yet, the no-hiding theorem, a theorem proved by Samuel Bronstein and Arun Patti in 2007, says that the information did not vanish. It is hidden. Specifically and provably hidden, in the quantum correlations between the products of the combustion and the environment. The no-hiding theorem is one of the least known and most important results in all of physics. Almost nobody outside the quantum information community has heard of it. The theorem deserves more attention than it gets. What it says is this: if a quantum system loses information, if the quantum state of a system becomes mixed, becomes less pure, becomes scrambled, that information must go somewhere. It cannot simply cease to exist. And the somewhere is not arbitrary. The information does not split up and go partially here and partially there. It does not stay associated with the original system in a hidden way. It goes into the global correlations of the environment. The correlations between all the environmental degrees of freedom that interacted with the system. And once there, it cannot be recovered by any local measurement of any piece of the environment. It can only be recovered by a global measurement of the entire environment simultaneously. This is a mathematical theorem. It has been proved. It follows from the axioms of quantum mechanics, and it has a consequence that is almost shocking in its directness. The environment is a library, not a perfect readable archive. An archive that has been scrambled beyond any practical hope of recovery, but that nevertheless contains, by mathematical necessity, every record of everything that has ever happened within it. This is the no-hiding theorem applied at cosmological scale. The universe is a library in which nothing has ever been thrown away. Every book is still there, every word, every thought that generated the words, every electrochemical signal in every brain that thought every thought. All of it. Hidden, inaccessible, but present. As rigorously real as anything physics can describe. Now let us understand why this has to be true. Why physics cannot allow the alternative. Why information conservation is not just an observation about how the universe happens to work, but a necessity, something that follows inevitably from the mathematical structure of quantum mechanics. The argument is about probabilities. Quantum mechanics describes the world in terms of probability amplitudes. The quantum state of a system is a mathematical object, a wave function, in the simplest cases that encodes the probability of every possible outcome of every possible measurement you could perform on the system. The evolution of this mathematical object in time is governed by the Schrödinger equation. And the Schrödinger equation has a specific mathematical property. It is unitary. The evolution operator it defines is a unitary operator. meaning it preserves the norm of the wave function. Why does this matter? Because the norm of the wave function is related to total probability. Preserving the norm means preserving total probability. Total probability must always sum to 1. You must always be able to get some outcome when you measure.
If total probability were not preserved, you could have situations where the probabilities of all possible outcomes sum to less than 1, meaning there is some probability that the system simply ceases to exist, or sum to more than 1, meaning probability has been created from nothing. Both would be absurd. Both would violate something more fundamental than any specific physical law. They would violate the coherence of the probability framework itself. So unitarity is not a specific physical assumption about how the world happens to work. It is a mathematical necessity imposed by the requirement that probability makes sense. And unitarity means information conservation. If the evolution is unitary, if the norm is preserved, then there is a one-to-one correspondence between initial states and final states. Every initial state maps to a unique final state, and every final state came from a unique initial state. The mapping is invertible. Given the final state, the initial state can be recovered uniquely. This means the information in the initial state is still in the final state. It must be. If the mapping is one-to-one, the same amount of information is in both. If information could be destroyed, if two different initial states could evolve to the same final state, the mapping would not be one-to-one. It would be many-to-one. And a many-to-one mapping is not unitary. And a non-unitary mapping does not preserve probability norms. And not preserving probability norms means probabilities do not make sense. The conservation of information is the price of having a consistent probability theory. Physics requires information conservation because without it, the mathematical framework of quantum mechanics collapses into incoherence. This is not a contingent fact about our universe. It is a structural necessity of any universe described by a consistent probabilistic theory. The universe cannot forget because forgetting would break mathematics. Now we need to go somewhere stranger. We need to talk about where, in a spatial sense, the information is. Not just that it is conserved, we have established that, but where it lives, how it is stored, what the geometry of the universe's information archive looks like.
Hawking worked harder on the problem. He did a careful quantum mechanical calculation, and he found, to his own surprise, that black holes do radiate. That quantum mechanics, applied to the vacuum near a black hole's event horizon, produces particle-antiparticle pairs, with one partner escaping as radiation and one falling in. The black hole has a temperature. It emits radiation, Hawking radiation, and this confirmed Bekenstein's result. Black holes have entropy. The entropy is proportional to the area of the horizon. But this creates an immediate puzzle, more profound than the one Bekenstein was trying to solve. If the entropy of a black hole is proportional to its horizon area, not its volume, then the information content of the black hole is in its surface, not its interior. But the black hole is not special in being a region of space. It is just an extreme case of a gravitational field. The same logic should apply, in some form, to any region of space. And if the information content of any region of space is proportional to its surface area rather than its volume, then we are being told something profound about the nature of space itself. We are being told that the world is two-dimensional, not in appearance. The world looks three-dimensional, and in every everyday sense is three-dimensional. But in its information content, in the number of bits required to fully specify what is happening in any region of space, the world is two-dimensional. The relevant quantity is the surface area of the region, not the volume. This is the holographic principle. It was formalized by Gerard 't Hooft
in 1993 and by Leonard Susskind in 1994, drawing on both Bekenstein's entropy bound and on earlier work in string theory. And it says, in its most radical form, that any physical description of a region of space is completely encoded in a description on the boundary of that region.
This is the holographic principle, and it will require us to rethink something fundamental about the relationship between space and information. Start with black holes. In 1972, Jacob Bekenstein, a young graduate student working under John Wheeler at Princeton, asked a question that his colleagues initially dismissed as confused. He asked, "Do black holes have entropy?" The question seemed wrong on its face. Entropy is a measure of disorder of the number of ways a system can be arranged internally while looking the same from the outside. A black hole, classically, has no internal structure visible from the outside. It is described entirely by three numbers: its mass, its charge, and its angular momentum. How could something with no visible internal structure have entropy? But Bekenstein had noticed something troubling. The second law of thermodynamics says that the total entropy of a closed system can never decrease. But if you throw a bucket of hot gas into a black hole, you are throwing a high entropy object into an object that, classically, has no entropy. The entropy of the gas disappears from the universe's accessible state. The total entropy of the universe seems to decrease. This cannot be right. The second law cannot be wrong. Therefore, the black hole must have entropy. It must acquire entropy when you throw the gas in. The entropy does not vanish. It goes into the black hole. Bekenstein calculated that the entropy of a black hole is proportional to the area of its event horizon, not to its volume, to its area, specifically to the area in units of the Planck length squared, the fundamental quantum gravitational length scale. 1 unit of entropy per 4 Planck areas of horizon. This result is called the Bekenstein bound, and it is one of the most important results in theoretical physics of the past 50 years. Stephen Hawking initially resisted Bekenstein's claim. If a black hole has entropy, Hawking pointed out, it must also have a temperature. A temperature makes sense only if an object can radiate, and black holes, by definition, cannot radiate. Nothing escapes a black hole. Not approximately encoded, not partially encoded, completely. Every physical fact about the interior is recoverable from the boundary description. The three-dimensional world is a hologram. The two-dimensional boundary is the fundamental description. This was elevated from speculation to something approaching mathematical certainty in 1997, when Juan Maldacena published what became known as the ADS-CFT correspondence. Maldacena showed, in the context of a specific family of spacetimes, that a theory of quantum gravity in the interior of the spacetime is exactly equivalent in all physical predictions to a non-gravitational quantum field theory on the boundary. The two theories are dual to each other. They describe the same physics in different variables. The duality is exact, not approximate. Every calculation done in the bulk gravitational theory has an exact counterpart in the boundary field theory, and vice versa. The two descriptions are not approximately equivalent at large scales or in some limited regime. They are completely equivalent at all scales, in all regimes. This means that the three-dimensional physics happening in the bulk of the spacetime, all the gravitational dynamics, the quantum fields, the particle interactions, everything is completely encoded in the two-dimensional quantum field theory on the boundary. The boundary is the reality. The bulk is the hologram. In the years since 1997, the ADS-CFT correspondence has been tested extensively, in the sense that predictions have been computed in both the bulk and boundary descriptions and found to agree.
It is as well established as any major result in theoretical physics that lacks a direct experimental test.
And while our universe is not technically an anti-de Sitter space, our cosmological constant is positive, giving our space-time a de Sitter character rather than anti-de Sitter. The expectation in the physics community is that holography is a general feature of quantum gravity, not an artifact of the specific geometry Maldacena worked in. If holography is general, then the observable universe has a boundary, a cosmic horizon beyond which the universe has been expanding too fast for light to reach us, forming a surface that bounds our observable region. And the holographic principle says that the complete physical description of everything in the observable universe is encoded on that surface, encoded at Planck resolution, 1 bit per Planck area. The total information content of the observable universe is finite, approximately 10 to the power of 122 bits, calculated from the horizon area in Planck units. An enormous but finite number. And you are part of that encoding. Your body, your brain, your history, your thoughts, all of it is part of the Planck scale bit pattern on the cosmic horizon that constitutes the fundamental physical description of the universe. Not as a copy, not as a representation, as the fundamental thing. The three-dimensional version of you that you experience as yourself is the hologram. The two-dimensional description on the boundary is the ground truth. Let that land for a moment. The most fundamental physical description of you is not located where you think you are. It is on the boundary of the observable universe, encoded at Planck scale in the holographic data of the cosmos. And that data is conserved by the unitarity of quantum evolution, by the no-hiding theorem, by the information conservation laws that make quantum mechanics coherent. You cannot be erased from the boundary. You cannot be erased from the universe's fundamental description of itself. You are there, permanently, encoded in the two-dimensional bit pattern at the edge of the observable cosmos. Now we need to confront the hardest part of the story, the part that required the most painful revision of our best physical theories, the part where everything we have established seems to collide with one of the most extreme objects in the universe. We need to talk about the information paradox. We need to talk about what black holes do to information and what the resolution of that problem tells us about the permanence of everything. Stephen Hawking's 1974 discovery of Hawking radiation was one of the great triumphs of theoretical physics. It combined general relativity and quantum mechanics, two theories that have resisted unification for a century, in a semiclassic calculation that produced a specific quantitative result, as it mentioned the chemical that operate when they were often the time of yourself. In a simple quantitative result, black holes radiate thermally. They have a temperature inversely proportional to their mass. They slowly lose mass and eventually evaporate. The result was beautiful. It was also disturbing, because Hawking radiation, in Hawking's original calculation, is perfectly thermal, featureless, random. The radiation produced by an evaporating black hole is indistinguishable from the radiation produced by any black body at the same temperature. It carries no information about what the black hole swallowed. A black hole swallows an encyclopedia and returns random thermal noise. If this is right, if Hawking's calculation is exactly correct, then information is genuinely destroyed in black hole evaporation. The quantum state of everything that fell into the black hole is gone. Not scrambled, not hidden, not distributed into inaccessible correlations. Gone, replaced by featureless randomness. This would be a direct violation of unitarity. It would mean that the evolution of the universe
is not unitary. It would mean that the mathematical framework of quantum mechanics at the level of quantum gravity breaks down. This is the information paradox, and it is not a small puzzle. It is a direct conflict between general relativity and quantum mechanics at their most fundamental level. Hawking himself held, for nearly 3 decades, that information was genuinely destroyed. He believed that black holes represented a genuine violation of quantum unitarity, that quantum mechanics was not a complete theory, that its information conservation principles failed in the presence of strong gravity. Most physicists disagreed, not because they had a solution, they didn't,
but because violating unitarity, violating information conservation, seemed to break too many other things. If information can be destroyed in black holes, the entire framework of quantum mechanics is suspect. The consistency of probability theory is threatened. Something very deep would be wrong. The resolution began to come in pieces from many directions simultaneously. Don Page computed, in 1993, what the information content of the Hawking radiation should look like if the evaporation is unitary. The result is called the Page curve. It describes how the entanglement entropy of the emitted radiation should evolve over the lifetime of the black hole. In the first half of the evaporation, the entanglement entropy of the radiation grows. This is expected. The radiation is becoming more entangled with the remaining black hole as more of it is emitted. At the Page time, roughly the midpoint of the evaporation by mass, the radiation carries more than half the total information. After this point, if the evaporation is unitary, the entanglement entropy of the radiation must begin to decrease. Information must start coming out. The correlations in the radiation must start encoding information about what the black hole swallowed. The Page curve is a prediction, a specific quantitative prediction about what unitary black hole evaporation looks like. For 20 years after Don Page computed it, no one could derive the Page curve from first principles. It was what the answer should be, but no one could show it was actually what the dynamics produced. Then, in 2019, something remarkable happened. 2 groups of physicists working independently found a way to calculate the Page curve from the actual equations of quantum gravity. Their approach used a combination of the holographic duality, a technique from quantum information theory called the replica trick, and a new concept called the island formula. Let the ideas that have been moving through you tonight settle into wherever they settle. Not the analytical part of the mind that has been following the arguments, the other part, the part that responds to things that are true in a different way, the heat of a thought, the no-hiding theorem, the holographic boundary, the quantum hair of black holes, the unitary evolution of everything, all of it pointing in the same direction. The universe is not a place where things happen and are then lost. The universe is a place where things happen and are then encoded in the quantum correlations of matter, encoded in the holographic boundary data, encoded in the global wave function of everything, encoded permanently by the laws of physics, with the same indelibility that mathematical truths are permanent. This night is in the universe. The specific configuration of this hour, the thoughts that have moved through this room, the particular quality of this quiet, the specific pattern of quantum events in every brain that is being shaped by these words tonight. All of it is being added right now to the universe's permanent archive. The archive does not close. The archive does not fill up. The archive does not distinguish between the momentous and the ordinary. Everything goes in. Everything stays.
the thoughts you will lose at the edge of sleep tonight, the ideas that will dissolve into thermal noise as your brain lets go of them. They will be in the archive, not as readable text, as quantum correlations in the matter around you, as tiny modifications to the entanglement web of the universe, as small increments to the holographic boundary data of the cosmos. Permanent, real. Part of what the universe is, in the only sense that matters physically. You are part of what the universe is. You have always been part of what the universe is.
And the laws of physics, the irreversibility of quantum measurement, the unitarity of quantum evolution, the Bekenstein bound, the no-hiding theorem, the holographic principle, all of them together say the same thing. The universe does not lose you. It cannot lose you. It is not capable of losing you. You are encoded in it at the most fundamental level, on the boundary, in the correlations, in the archive. Permanent, real, safe. Let that be enough for tonight. Let the breath slow to whatever pace it finds on its own. Let the body go as heavy as it wants to go. The universe is handling the rest. It always was. It always will. You are in good hands. The universe's hands are mathematics, and mathematics does not forget. There is something we have not yet fully examined, and it requires us to slow down considerably. We have been moving through the physics at a pace that serves understanding, but we have not yet sat with what unitary evolution actually means in terms of human scale. What it means when you apply it not to particles, but to the full, lived, textured experience of being a person in the world. Let us try. Unitary evolution, we have said, is reversible. The quantum state of any closed system at any time contains all the information needed to reconstruct every prior state of that system. The information flows through time forward, in the ordinary experience of a universe with an entropic arrow, but is never destroyed. The state at one time is always, in principle, recoverable from the state at any later time by running the evolution backward. What does this mean for a life? A life is a physical process, a long, complex, thermodynamically expensive physical process that begins with the organization of matter into a specific biological structure and ends with the dispersal of that structure. Between beginning and end, the physical system that constitutes a life executes an enormous number of quantum events. Neurons fire, molecules are synthesized and broken down, Photons are emitted and absorbed. The body interacts with its environment in ways that leave quantum informational traces in the environment and modify the quantum state of the body. All of this is unitary evolution. The quantum state of the physical system, the body, embedded in its environment, evolves unitarily through time. No information is lost. Every prior state is, in the mathematical structure of unitary evolution, encoded in every subsequent state. The universe could not have arrived at its current quantum state, the state it is in right now, at this moment, without producing you. Your information is part of the current state. The current state is the unique product of 13.8 billion years of evolution from the initial state. Therefore, your information was in the initial state. You are always going to be here. Not as a destiny in any supernatural sense, as a mathematical necessity, as a consequence of initial conditions and unitary dynamics. You are what the universe was always going to produce. You are a specific term in the cosmic calculation. You are a consistency condition, a feature that had to be there for the calculation to produce the result it produced. And the calculation is permanent. The initial state is fixed. It cannot be changed. The evolution from that state is unitary and therefore information preserving. The result of that evolution, the current state of the universe, which includes you, is the permanent consequence of those initial conditions. You are a permanent feature of the universe's calculation, not of the universe's physical arrangement, which will change.
not of the organized structure of matter that constitutes your body, which will disperse, not of the conscious experience that your physical organization sustains, which will end, but of the calculation, of the information, of the quantum state and its evolution. That permanence is a specific kind of permanence. It is not the permanence of continuing to exist. It is the permanence of having always existed in the calculation, the permanence of a number that appears in an equation. The equation is permanent. The number is part of the equation. The number is permanent. You are a number in the universe's equation. You cannot be removed from it. The equation will not change. Now let us talk about what happens to the information that constitutes you when your physical organization disperses.
When the atoms of your body are no longer arranged in the specific configuration that sustains consciousness. When the thing that has been you dissolves back into the wider environment.
Physically, you know what happens. The atoms disperse. They enter the environment, the soil, the air, the water, the biological systems of other organisms. They are recombined and reformed in new configurations. The atoms that were you become part of other systems. They persist as matter, but the specific organization that was you, the configuration that gave rise to your experience, is gone. From the information perspective, something different happens. The information that constituted you does not disperse. It cannot disperse in the quantum informational sense because the no-hiding theorem prevents it. Instead, the information is distributed into the environment, hidden in the quantum correlations of the matter that your atoms interact with as they disperse, encoded in the entanglement web that connects all the atoms that were part of you with all the atoms they interact with as they enter new configurations. The information becomes maximally scrambled, maximally distributed, maximally inaccessible, but not erased. The information about you, the complete quantum description of the physical system you have been, joins the universe's archive, the vast, inaccessible, permanent archive of every quantum event that has ever occurred. You join the web, not as a distinct entity, not as a recoverable pattern, as information woven into the correlations of everything, permanent, inextricable, real. There is a meditation tradition in Buddhism, in certain forms of Stoicism, in contemplative practices across many cultures, that involves resting in the recognition that you are made of the same stuff as everything else, that the boundary between you and the world is less fixed than it appears, that the self is a temporary organization of matter and energy that participates in the larger flows of the universe. Physics confirms this, not as a metaphor, but as a physical fact. You are a temporary organization of matter and energy.
The organization is specific and precious and sustained by complex thermodynamic processes that require constant maintenance. The organization will end, but the matter and energy are not yours. They were part of the universe before you, and they will be part of the universe after. And the information carried in the quantum state of that matter, the information that includes the record of your having organized it in the specific way you did, is permanently in the universe. The matter flows through you. The information of you flows into the universe. Both directions of flow are permanent in their own way. The matter returns to the pool from which it came, carrying with it the quantum signatures of having been part of you. The information of you is added to the universe's archive, permanently encoded in the entanglement web that remembers everything. This is not comfort in the simple sense. It does not make death easier, or grief less real, or the ending of experience less final. The experience ends. That is real,
and it is significant, and no amount of physics changes it. But it is a specific kind of permanence that physics offers. The permanence of information. The permanence of having been real. You have been real. The universe knows it, not in the sense of an observer watching you, in the sense that your having been real is encoded in the universe's current quantum state as a mathematical fact that follows from the laws of physics and cannot be undone by any subsequent event. Let the body settle now.
Every state you have ever been in is, in the mathematical structure of the universe's unitary evolution, encoded in your current state. Not accessible, your body is not a perfect quantum memory, and you cannot reconstruct your prior states from your current ones in any practical sense. But present. As the inverse of the unitary transformation that has evolved you to this moment, and every interaction you have had with the environment, every photon you have emitted, every molecule you have exhaled, every sound you have made, every thermal fluctuation you have contributed to the matter around you, all of it has modified the quantum state of the environment in ways that, by the no-hiding theorem, preserve information about you. The environment around you right now has been shaped by your presence in it, not in a macroscopic way that anyone could measure, in the quantum correlational structure of the matter near you, in the pattern of entanglements between molecules that encode, in their global correlations, information about every quantum event you have been involved in. And beyond the local environment, you are encoded in the holographic boundary data of the universe, in the Planck scale pattern on the cosmic horizon that constitutes the fundamental physical description of everything. Your specific information is there, not as a copy, not as a representation, but as the fundamental ground truth from which the three-dimensional version of you is derived. You are permanent in the universe's data, not in any sense that matters to the experience of consciousness, not in any sense that softens the fact of mortality or makes the ending of experience less real. The experience will end. The organized physical system that sustains consciousness will disperse. That is unavoidable. But the information that constituted you, the complete quantum description of every state you have ever occupied, is in the universe, in the holographic boundary, in the quantum correlations of the environment, in the global wave function of the cosmos. It cannot be removed. It cannot be erased. The laws of physics do not permit it. You are a fact that the universe is required to contain. And here is the deepest thing. The thing that requires us to understand unitarity, not just as a technical property of quantum evolution, but as a statement about the relationship between past and present. If the universe evolves unitarily, and all the evidence says it does, then the current quantum state of the universe encodes not just the present, but the entire past. The complete history. Every state the universe has ever been in is, in the inverse of the unitary evolution, present in the current state. The past does not cease to exist when it becomes past. It becomes encoded in the present. The present is not just the present. It is the present plus the complete record of everything that led to it. The record is not accessible to read. It would require reversing the unitary evolution of the universe, which would require more computational resources than the universe contains. But the record is there. Everything that has ever happened is in the current quantum state of the universe. Not as a memory that might fade, as a mathematical necessity, as a consequence of the invertibility of unitary evolution. The past is not gone. The past is encoded, and encoding is permanent. Let us slow down here and think about what encoding means, because the word can be used loosely, and we need it to be precise. When we say information is encoded in the quantum correlations of the environment,
we mean something specific. We mean that there exists a mathematical description, a quantum state, in the technical sense of the environment, and that this quantum state contains within it, as a consequence of its specific correlational structure, information about the events that shaped it. The information is not in any single part of the environment. It is not in the molecules nearest to the event that produced it. It is distributed globally. Every part of the environment has been influenced in exponentially small ways by every quantum event that has ever occurred. And the global pattern of these influences, the totality of quantum correlations across the entire environment, contains, encoded within it, information about all of them. This is not mystical. This is quantum mechanics. Every quantum system that interacts with another quantum system becomes entangled with it. The entanglement is a physical relationship between the quantum states of the two systems. It is as real as any other physical quantity, and it persists. It persists until something actively breaks it, until a decoherence process scrambles the correlations. But even decoherence does not destroy the correlations. It distributes them further, scrambles them into larger and larger systems, makes them more and more inaccessible, but does not remove them. The universe is filled with a vast web of entanglement. Every particle that has ever interacted with every other particle is, in some sense, still connected to it. The connection is expressed through quantum correlations that span the universe. The correlations are exponentially weak. They cannot be detected. They cannot be exploited for any practical purpose. But they are there. This web of entanglement is the universe's memory. The universe does not store its memory in any single location. It stores it everywhere, distributed across all its entanglement correlations. Every event adds to the entanglement. Every interaction modifies the web. Nothing is removed. The universe accumulates memory without limit. And this accumulation is not a burden. It is not a storage problem. It is not something the universe has to manage. It is simply what quantum systems do. They interact, they entangle, they distribute information into correlations. They remember, not through any active process of remembering, but through the passive persistence of quantum entanglement in the fabric of space-time. Now let us think about the time scale of this. The universe is 13.8 billion years old.
In 13.8 billion years of quantum evolution, every particle has interacted with enormous numbers of other particles. The entanglement web is, by now, incomprehensibly complex. The information encoded in the quantum correlations of the universe is the information of 13.8 billion years of quantum events. Every photon emitted by every star, every nuclear reaction in every stellar core, every electron that has ever jumped between orbitals, every proton that has ever been involved in a fusion reaction, every molecule that has ever formed or broken, every quantum event in every biological cell that has ever lived, every electrochemical signal in every nervous system that has ever fired. All of it is in the web. All of it is in the holographic boundary data. All of it is in the current quantum state of the universe. The universe has been taking perfect notes for 13.8 billion years. It has not missed a single event. It cannot miss a single event. Missing events is not something it has the capacity to do. This is what we mean when we say, the universe remembers everything, and you are part of everything. Every thought that has completed itself and dissolved at the edge of sleep. Every decision that produced its small Landauer heat. Every quantum event in every neuron that has ever fired in your brain. Every photon that has left your body. Every molecule that has diffused into the air around you. All of it is in the universe's record. All of it is in the holographic boundary. All of it is woven into the entanglement web that constitutes the universe's memory. You cannot be removed from this record, not by death, not by the passage of time, not by the dispersal of the atoms that constitute you into the wider environment.
not by the eventual heat death of the universe, in which all organized structure dissolves, and all temperature differences equalize, and all usable energy is expended. Even in the heat death, the information is there, scrambled past all recovery, uniformly distributed across the maximum entropy state, encoded in the correlations of a universe that has reached thermodynamic equilibrium. But there, the heat death is not information death. The maximum entropy state is not the zero information state. The maximum entropy state is the state of maximum scrambling information distributed as uniformly as possible across all available degrees of freedom. The information content of the universe does not decrease as entropy increases. It remains constant. It is just progressively more scrambled, progressively less accessible, progressively more hidden. But the no-hiding theorem still holds. The information is still in the global correlations. Even at heat death, the information about you, about every event in your life, about every thought you have had, about this specific night, is in the correlations of the universal quantum state, in the maximum entropy state of the universe, permanent. Now let us talk about the phrase that has been implicit in everything we have discussed tonight, and that deserves to be made explicit. The phrase is, "You are a consistency condition of the cosmic calculation." This phrase comes from thinking carefully about what unitarity means for a specific moment, this moment in the history of the universe. The universe has been evolving unitarily for 13.8 billion years. Starting from some specific initial quantum state at the Big Bang, whatever that state was, the universe has been evolving according to specific laws in a specific way. And it has arrived, by that specific evolution, at its current quantum state. The current quantum state includes you. This specific configuration of matter and energy and quantum correlations that constitutes you, here, now, is part of the universe's current quantum state. And the universe's current quantum state is the specific, unique result of 13.8 billion years of unitary evolution from the initial state. What this means is that the initial state of the universe, the quantum state at the Big Bang, encoded in its specific correlations and amplitudes all the information necessary to produce this current state, including you, including this moment. You were in the initial state, not as a conscious being, not as an organism, but as information. The information that has evolved over 13.8 billion years of unitary dynamics into the specific configuration that is you. The Big Bang contained, encoded in the pattern of its quantum fluctuations, the information that would give rise to every galaxy, every star, every planet, every organism, every thought, including the specific organism you are and the specific thought you are having right now. This is not mystical. This is what it means for evolution to be unitary. Unitary evolution is deterministic in the sense that the current state follows uniquely from the initial state. Not deterministic in the classical sense, quantum mechanics has genuine randomness in measurement outcomes, but deterministic in the sense that the quantum state's evolution is fixed once you know the initial state and the Hamiltonian. You were determined by the initial conditions, not in a way that makes your choices less real, not in a way that undermines the reality of your experience. Your choices are part of the quantum state. They are part of what the unitary evolution produces. The evolution does not go around your choices, it includes them. Your decision-making is part of the physics, but it means that you are a necessary consequence of the universe's evolution from its specific initial state.
The universe could not have arrived at its current quantum state, the state it is in right now, at this moment without producing you. Your information is part of the current state. The current state is the unique product of 13.8 billion years of evolution from the initial state. Therefore, your information was in the initial state. You are always going to be here. Not as a destiny in any supernatural sense, as a mathematical necessity.
as a consequence of initial conditions and unitary dynamics. You are what the universe was always going to produce. You are a specific term in the cosmic calculation. You are a consistency condition, a feature that had to be there for the calculation to produce the result it produced. And the calculation is permanent. The initial state is fixed. It cannot be changed. The evolution from that state is unitary and therefore information preserving. The result of that evolution, the current state of the universe, which includes you, is the permanent consequence of those initial conditions. You are a permanent feature of the universe's calculation, not of the universe's physical arrangement, which will change, not of the organized structure of matter that constitutes your body, which will disperse, not of the conscious experience that your physical organization sustains, which will end, but of the calculation, of the information, of the quantum state and its evolution. That permanence is a specific kind of permanence. It is not the permanence of continuing to exist. It is the permanence of having always existed in the calculation, the permanence of a number that appears in an equation. The equation is permanent. The number is part of the equation. The number is permanent. You are a number in the universe's equation. You cannot be removed from it. The equation will not change. Now let us talk about what happens to the information that constitutes you when your physical organization disperses.
When the atoms of your body are no longer arranged in the specific configuration that sustains consciousness. When the thing that has been you dissolves back into the wider environment.
Physically, you know what happens. The atoms disperse. They enter the environment, the soil, the air, the water, the biological systems of other organisms. They are recombined and reformed in new configurations. The atoms that were you become part of other systems. They persist as matter, but the specific organization that was you, the configuration that gave rise to your experience, is gone. From the information perspective, something different happens. The information that constituted you does not disperse. It cannot disperse in the quantum informational sense because the no-hiding theorem prevents it. Instead, the information is distributed into the environment, hidden in the quantum correlations of the matter that your atoms interact with as they disperse, encoded in the entanglement web that connects all the atoms that were part of you with all the atoms they interact with as they enter new configurations. The information becomes maximally scrambled, maximally distributed, maximally inaccessible, but not erased. The information about you, the complete quantum description of the physical system you have been, joins the universe's archive, the vast, inaccessible, permanent archive of every quantum event that has ever occurred. You join the web, not as a distinct entity, not as a recoverable pattern, as information woven into the correlations of everything, permanent, inextricable, real. There is a meditation tradition in Buddhism, in certain forms of Stoicism, in contemplative practices across many cultures that involves resting in the recognition that you are made of the same stuff as everything else, that the boundary between you and the world is less fixed than it appears, that the self is a temporary organization of matter and energy that participates in the larger flows of the universe. Physics confirms this, not as a metaphor, but as a physical fact. You are a temporary organization of matter and energy.
The organization is specific and precious and sustained by complex thermodynamic processes that require constant maintenance. The organization will end, but the matter and energy are not yours. They were part of the universe before you, and they will be part of the universe after. And the information carried in the quantum state of that matter, the information that includes the record
of your having organized it in the specific way you did is permanently in the universe. The matter flows through you. The information of you flows into the universe. Both directions of flow are permanent in their own way. The matter returns to the pool from which it came, carrying with it the quantum signatures of having been part of you. The information of you is added to the universe's archive, permanently encoded in the entanglement web that remembers everything. This is not comfort in the simple sense. It does not make death easier or grief less real or the ending of experience less final. The experience ends. That is real, and it is significant, and no amount of physics changes it. But it is a specific kind of permanence that physics offers. The permanence of information. The permanence of having been real. You have been real. The universe knows it, not in the sense of an observer watching you, in the sense that your having been real is encoded in the universe's current quantum state as a mathematical fact that follows from the laws of physics and cannot be undone by any subsequent event. Let the body settle now.
Every version of you that has ever existed is, in the quantum mechanical sense, still accessible from the current state of the universe. Not accessible in practice, the computational resources required would exceed anything physically realizable, but accessible in principle, in the mathematical structure. The child you were is encoded in the universe's current state, not as a memory that might be distorted or lost, as a quantum informational fact that follows from the laws of physics and cannot be removed by any subsequent event. The specific configuration of quantum states that constituted you at every age you have ever been is in the universe, in the global wave function, in the entanglement web, in the holographic boundary. You have not left those ages behind in the informational sense. They are still there, encoded, permanent, as part of the universe's unitary history. This has no practical consequence for lived experience. You cannot access those states. You cannot return to them. The thermodynamic arrow runs forward, and the entropic gradient that constitutes your experience of time means you move forward through the encoding, accumulating new states, never recovering old ones in any useful sense. But the encoding is there. The accumulation is permanent. Every version of you that has ever existed has left its permanent mark on the universe's quantum state. Now let us examine something that gets to the heart of why any of this matters, which is the relationship between information and meaning. We have been talking about information in the technical Shannon information sense. Bits, quantum states, entropy. These are mathematical abstractions, and it is fair to ask what they have to do with the things that matter, with the specific texture of experience, with love, grief, beauty, understanding, and the other things that make a life feel like something rather than nothing. The answer requires us to be careful, because the connection between information and meaning is real, but not simple.
Information, in the technical sense, is content-free. A bit is a bit, regardless of what it represents. The information content of a complex thought and the information content of a temperature fluctuation in a cup of coffee are measured by the same unit. Shannon's entropy does not care about significance, but meaning is a specific kind of information. It is information organized in a way that matters to a conscious system. Information whose specific content is relevant to the conscious system's model of the world, its values, its projects, its relationships. When we say that the universe preserves information, we are saying something about all information, including the information that has meaning, including the specific configuration of quantum states that constituted a moment of understanding, a moment of love, a moment of grief.
The universe preserves these with the same indifference and the same completeness that it preserves the information content of a rock. It does not preserve meaning. It preserves the information that, when organized in a conscious system, gives rise to meaning. The meaning was real when it occurred. The information that constituted it is permanently encoded in the universe. The meaning itself, the specific quality of being, that meaning for that conscious system at that moment existed, and the universe's record of it existing is permanent. This is not the same as saying meaning is permanent in any simple sense. The experience of meaning is not preserved. What is preserved is the physical fact that a specific physical system was in a specific state that, when that state occurred, constituted meaningful experience. The experience was real. The universe knows it was real, in the only way physics permits knowing anything, by having the information of it encoded in its quantum state. This is enough. It has to be enough, because it is what the universe offers. The universe does not offer the continuation of experience.
It does not offer the perpetuation of consciousness beyond the physical systems that sustain it. It does not offer the kind of permanence that conscious beings, fearing their own ending, most want. But it offers this. It offers the permanent record of having been, the permanent encoding of every event, every interaction, every state in the long, complex, thermodynamically expensive process of a life. The permanent presence, in the quantum state of the cosmos, of the information that constituted every moment. This is what the physics says, clearly, without ambiguity, as a consequence of laws so fundamental that the coherence of mathematics requires them. The universe remembers. It cannot forget. And what it remembers is everything, including you. Now I want to spend time on something that we have mentioned, but not fully explored, which is the relationship between the holographic principle and identity. Because the holographic principle does something strange to the ordinary concept of where you are. You think you are here, in this specific location in space, inside a body, in a room, at a specific set of coordinates, and you are right. The three-dimensional version of you is exactly where you think it is. But the holographic principle says that the three-dimensional version is not the most fundamental version. The most fundamental physical description of you is not located in three-dimensional space where your body is. It is located on the two-dimensional boundary of the observable universe. You are permanent in the only way that physics permits anything to be permanent. And physics is not known for making promises it cannot keep. Good night. We have established the foundation. Now let us build upward from it into the territory that makes quantum information theory genuinely strange. The territory where the abstract mathematics of unitarity and holography start to say specific things about the structure of the universe that feel, when you sit with them carefully, like they are addressing something fundamental about what it means for anything to exist at all. Let us talk about decoherence. Because decoherence is the process that connects the quantum world we have been describing, the world of superpositions and entanglement and global wave functions, to the ordinary classical world you experience when you open your eyes. And understanding decoherence is crucial for understanding how information moves from the quantum level to the classical level, and what happens to it along the way. A quantum system in superposition exists, in a real physical sense, in multiple states simultaneously. A photon can have two polarizations at once. An electron can be spinning up and down simultaneously. These are not states of our ignorance about the photon or the electron. They are the actual physical condition of those systems, described fully by the quantum wave function. When a quantum system interacts with a large environment with billions of particles in a gas, or in the material of a detector, or in a biological tissue, something happens that looks, from the outside, like the superposition collapses. The system ends up in one
definite state or the other. The multiplicity of the quantum superposition appears to vanish, replaced by the classical definiteness of ordinary experience. This is decoherence, and for decades, it was not fully understood. Physicists knew it happened, but argued about what exactly it meant.
The modern understanding, developed primarily by Wojciech Zurek in the 1980s and 1990s, is this.
Decoherence does not actually collapse the quantum superposition, it spreads it. The superposition that was localized to a single quantum system spreads, through entanglement, into the environment. The quantum correlation between the two states of the original system becomes a quantum correlation between enormous numbers of environmental particles.
The superposition is still there. It is just distributed so widely that no practical measurement can detect it. The interference effects that are the signature of quantum superposition, the effects that show up in double-slit experiments and quantum computers, average to zero when you average over all the environmental degrees of freedom. The system looks classical. It behaves classically. For all practical purposes, it is classical. But it is not, in the quantum mechanical sense, classical. The global wave function of the system, plus its environment, is still in a quantum superposition. The decoherence has not removed the quantum features. It has hidden them. The quantum correlations are in the environment. They are inaccessible to any practical measurement. They are scrambled across so many environmental degrees of freedom that recovering them would be technically impossible. But they are there. The no-hiding theorem applies. The information about the original quantum superposition, the information about both branches of the superposition that the system was in before decoherence, is in the global quantum correlations of the environment. Every time a quantum superposition decoheres in your brain, every time a quantum event at the neural level becomes a classical event, the quantum information about the superposition is hidden in the environment around the neuron, in the warm, wet, biological medium that surrounds your neurons, in the thermal bath of your body, in the infrared photons radiated by your skin into the air of the room. Every thought, every decision, every moment of experience, the quantum information about every one of these events is hidden in the environment. Not erased, hidden. The room around you is a quantum archive of your mental life. Not a readable archive. Not an archive that any technology could decode. But a real, physical, quantum informational archive maintained by the no-hiding theorem, encoded in the global correlations of the matter around you. You think. The thought decoheres. The quantum information of the thought disperses into the environment. The environment hides it. The information is permanent. This is the cycle that runs continuously throughout your conscious life, through every life, through every thought that has ever been thought by any mind that has ever existed. The biosphere of Earth is a quantum archive of every mental event that has ever occurred in every mind that has ever existed on this planet. Not readable, not recoverable, but there, encoded in the quantum correlations of the planet's matter, the air, the water, the soil, the rock modified by billions of years of biological and mental activity. When you breathe the air, you breathe matter whose quantum state has been shaped by the mental activity of billions of humans who have breathed it before. Not their thoughts, not their memories, not anything recoverable or meaningful in the human sense, but the quantum informational trace of their having breathed it, their having lived in it, their having thought thoughts that decohere into it. This is not mysticism. This is quantum mechanics. The planet is a quantum memory of everything that has ever happened on it.
Now let us look more carefully at one of the central players in the information paradox resolution: entanglement entropy. Entanglement entropy is a measure of how entangled a quantum system is with its environment. When a system is not entangled at all, when it exists in a pure, isolated quantum state, its entanglement entropy is 0. When it is maximally entangled with the environment, when its quantum state is completely mixed with the environmental degrees of freedom, its entanglement entropy is at its maximum value.
The entanglement entropy of a subsystem tells you how much information about that subsystem has leaked into the environment. It is a measure of how much of the system's quantum information is hidden in the correlations with the outside. For an evaporating black hole, tracking the entanglement entropy of the emitted Hawking radiation over the lifetime of the evaporation is how Page derived his curve. The entanglement entropy grows as the black hole emits. Radiation information is leaking from the black hole into the radiation. At the Page time, roughly halfway through the evaporation, the entanglement entropy peaks and begins to fall. The information is coming back, encoded in the correlations between early and late radiation. The Page curve is a specific prediction about how entanglement entropy behaves in unitary black hole evaporation. Its derivation in 2019 to 2020 was a breakthrough because it showed, for the first time, that the actual dynamics of quantum gravity produce information-preserving behavior consistent with unitarity. But the Page curve is also telling us something more general, which is this: the entanglement entropy of any quantum system is a measure of how much of that system's information has been shared with the environment. It is a measure of how widely the system's quantum information has been distributed. For a human being moving through the world, the entanglement entropy of the physical system constituting the human being is constantly growing. Every interaction with the environment, every photon absorbed and emitted, every molecule exchanged with the surrounding medium entangles the human system more deeply with the environment. The entanglement entropy grows. Information flows outward. More and more of the information that constitutes you is distributed into the environment, not lost. The no-hiding theorem prevents that, but shared, copied into the environmental degrees of freedom, written into the correlations. By the end of a life, the entanglement entropy of the physical system that constituted that life has grown enormous. The information about that system has been widely distributed into the air breathed, the surfaces touched, the light emitted, the molecules exchanged with thousands of other organisms and physical systems.
The information of a life spreads throughout the world, not randomly, specifically. Each interaction leaves a specific quantum informational mark. The totality of those marks is the quantum informational legacy of a life, the specific way in which the presence of that person modified the quantum state of the world they moved through. This legacy is permanent. Not permanent in the sense of lasting forever as an organized structure, permanent in the sense of being encoded in quantum correlations that cannot be removed. Every person leaves a quantum informational legacy in the world they inhabited. Not a readable legacy, not a legacy that anyone can access or decode, but a real, physical, permanent modification of the quantum state of the world. The world is different because you were in it. Specifically, precisely, quantum mechanically different. Permanently. Now let us examine Landauer's principle one more time from a different angle. We established that erasing information costs energy, that the thermodynamic cost of erasure is precisely calculable and connected to entropy increase. But there is another way to understand what Landauer's principle is saying that is perhaps even more illuminating. Landauer's principle is saying that information erasure is irreversible. Not in the sense that you cannot make an erasure happen, you can, and it happens constantly in every computer and every brain. But in the thermodynamic sense, erasure produces heat, and heat disperses into the environment, and dispersed heat cannot spontaneously regather. The process is thermodynamically irreversible, which means the information does not actually disappear. It becomes heat. Heat is energy distributed across many degrees of freedom. Energy is conserved. The information now encoded as heat is in the environment. Landauer's principle is not just a statement about the cost of erasure. It is a statement about where erased information goes. It goes into heat.
Heat is thermal motion of molecules. Thermal motion is kinetic energy distributed across molecular degrees of freedom. And the specific distribution of kinetic energy across molecular degrees of freedom is, according to the no-hiding theorem, a quantum state that encodes information about everything that has ever contributed to it. The heat is the archive. Not a readable archive. The information is in the thermal state of matter, distributed across uncountably many molecular degrees of freedom, mixed with all the other thermal energy from all the other physical processes that have contributed heat to the environment. But the archive is there. Every bit of information ever erased is in the thermal state of the universe. Every thought ever dissolved, every decision ever made and then forgotten, every moment of experience that produced its Landauer heat and then was gone from conscious access, all of it is in the heat. All of it is in the quantum state of the thermal environment. All of it is in the universe's archive. The universe has been collecting heat, and therefore collecting the information that heat encodes since the Big Bang. The thermal bath of the universe is, in the most precise physical sense, the most complete archive that exists. It contains the thermodynamic signature of every physical process that has ever occurred, encoded in the quantum correlations of the thermal degrees of freedom of all the matter that has ever been heated by anything. This is what we mean when we say the vacuum is full. Let the ideas that have been moving through you tonight settle into wherever they settle. Not the analytical part of the mind that has been following the arguments, the other part, the part that responds to things that are true in a different way, the heat of a thought, the no-hiding theorem, the holographic boundary, the quantum hair of black holes, the unitary evolution of everything, all of it pointing in the same direction. The universe is not a place where things happen and are then lost. The universe is a place where things happen and are then encoded. Encoded in the quantum correlations of matter, encoded in the holographic boundary data, encoded in the global wave function of everything, encoded permanently by the laws of physics, with the same indelibility that mathematical truths are permanent. This night is in the universe. The specific configuration of this hour, the thoughts that have moved through this room, the particular quality of this quiet, the specific pattern of quantum events in every brain that is being shaped by these words tonight. All of it is being added, right now, to the universe's permanent archive. The archive does not close. The archive does not fill up. The archive does not distinguish between the momentous and the ordinary. Everything goes in. Everything stays. The thoughts you will lose at the edge of sleep tonight, the ideas that will dissolve into thermal noise as your brain lets go of them, they will be in the archive, not as readable text, as quantum correlations in the matter around you, as tiny modifications to the entanglement web of the universe, as small increments to the holographic boundary data of the cosmos. Permanent, real. Part of what the universe is, in the only sense that matters physically.
You are part of what the universe is. You have always been part of what the universe is.
And the laws of physics, the irreversibility of quantum measurement, the unitarity of quantum evolution, the Bekenstein bound, the no-hiding theorem, the holographic principle, all of them together say the same thing. The universe does not lose you. It cannot lose you. It is not capable of losing you. You are encoded in it at the most fundamental level, on the boundary, in the correlations, in the archive. Permanent, real, safe. Let that be enough for tonight. Let the breath slow to whatever pace it finds on its own. Let the body go as heavy as it wants to go. The universe is handling the rest. It always was. It always will. You are in good hands. The universe's hands are mathematics, and mathematics does not forget. There is something we have not yet fully examined, and it requires us to slow down considerably. We have been moving through the physics at a pace that serves understanding, but we have not yet sat with what unitary evolution actually means in terms of human scale. What it means when you apply it not to particles, but to the full, lived, textured experience of being a person in the world. Let us try. Unitary evolution, we have said, is reversible. The quantum state of any closed system at any time contains all the information needed to reconstruct every prior state of that system. The information flows through time forward. In the ordinary experience of a universe with an entropic arrow, but is never destroyed. The state at one time is always, in principle, recoverable from the state at any later time by running the evolution backward. What does this mean for a life? A life is a physical process, a long, complex, thermodynamically expensive physical process that begins with the organization of matter into a specific biological structure and ends with the dispersal of that structure. Between beginning and end, the physical system that constitutes a life executes an enormous number of quantum events. Neurons fire, molecules are synthesized and broken down, Photons are emitted and absorbed. The body interacts with its environment in ways that leave quantum informational traces in the environment and modify the quantum state of the body. All of this is unitary evolution. The quantum state of the physical system, the body, embedded in its environment, evolves unitarily through time. No information is lost. Every prior state is, in the mathematical structure of unitary evolution, encoded in every subsequent state.
The cosmic horizon.
A surface approximately 46 billion light-years away in every direction. On that surface, at Planck resolution, encoded in the quantum structure of whatever physical reality constitutes the boundary of the observable cosmos, is the information that describes you, along with the information that describes everything else in the observable universe. You are not three-dimensional at the most fundamental level. You are two-dimensional data on a very distant surface. The three-dimensional version that you experience as yourself, the body, the location, the continuous experience of being here, is a projection. A holographic projection, in the technical sense, of the two-dimensional boundary data. Not a fake projection, not an illusion. A real, physical, causally active projection that operates according to the three-dimensional physics of the bulk spacetime. The projection is real. The experiences it has are real. The choices it makes are real. The physics it participates in is real. But it is derived from the boundary. The boundary is more fundamental, and the boundary is conserved by unitarity. The information on the boundary cannot be removed. The Planck scale encoding of your information on the cosmic horizon is as permanent as any physical quantity. More permanent, in fact, than the three-dimensional projection. The three-dimensional version of you will disperse. The atoms will return to the environment. The organized structure will dissolve. the physical organization that sustains consciousness will end. But the boundary data does not disperse in the same way. The boundary data evolves according to the boundary theory, the two-dimensional quantum field theory that is dual to the bulk gravitational theory. And that evolution is unitary. The information is conserved. The encoding persists. The two-dimensional U on the boundary does not disperse the way the three-dimensional U does.
The two-dimensional U is the U that the universe keeps. This is a deeply strange idea. It requires us to rethink what we mean by location, identity, and persistence. It requires us to be comfortable with the idea that the most fundamental version of ourselves is not where we think we are. But it is what the holographic principle implies, and the holographic principle in the form of ADS-CFT is one of the most robustly confirmed theoretical frameworks in modern physics. We are, at the most fundamental level, patterns of information on the boundary of the universe. Patterns that are conserved, patterns that are permanent, patterns that the universe is required by its own laws to maintain. Let us think now about what all of this implies for how we relate to the past. We experience the past as gone, as irretrievable, as something that existed and then ceased to exist, leaving behind only the imperfect, degrading records of memory and physical traces. The past feels lost. We mourn it. We feel its absence as one of the most persistent features of temporal experience. But the physics says something different. The past is not gone. The past is encoded. In the current quantum state of everything, in the entanglement web of the universe, in the holographic boundary data, in the global wave function of the cosmos, the past has not ceased to exist. It has become inaccessible. Inaccessible is not the same as non-existent. The distinction matters. Not practically, we cannot recover the past, and nothing about the physics of information conservation changes that. The inaccessibility is real and total and permanent in the practical sense. But philosophically, emotionally, in terms of how we relate to what has been, the distinction matters. The past is not nothing. The past is everything that has ever happened, encoded in the quantum state of the universe, permanent and real and present in the most fundamental physical description of reality. The people we have loved who are no longer here, the moments that were beautiful and that have ended, the versions of ourselves we have grown past and cannot return to, the experiences that happened once and cannot happen again. None of them are nothing. All of them are encoded. All of them are in the universe. All of them are part of the permanent record that the laws of physics require the universe to maintain. This is not comfort in the sense of making grief easier. Grief is real, and its object is real. The specific presence, the specific conscious experience, the specific ongoing reality of a person or a moment. And that specific ongoing reality has ended and cannot be recovered. But the fact of having happened, the information of having occurred, the quantum physical record of having been real, that is permanent, and permanent is something. It is not nothing. There is a specific peace available when you stop treating the past as lost and start treating it as encoded. Not the peace of getting something back, the peace of recognizing that it was never really taken away, that the universe, in its meticulous, indifferent, mathematically necessary way, kept it, keeps it, will always keep it. You did not lose the moments that mattered. You gave them to the universe's archive, and the archive never closes. There is a phrase that appears in the context of the block universe, the view of time that Einstein's general relativity supports, in which past, present, and future all exist equally in the four-dimensional structure of space-time. The phrase is,
The present moment always will have been. Whatever is happening right now will always, in the future, have been something that happened. The future cannot unmake the past. 1,000 years from now, it will be true that this night occurred, that these ideas moved through this space, that whatever version of consciousness received them did so at this specific point in time and space. The present moment always will have been. Quantum information theory says something similar. Every quantum state that the universe has been in always will have been part of the universe's state. The unitarity of evolution means the information about that state cannot be removed from the universe's quantum history. The state happened. It was encoded. It will always have been encoded. You always will have been. This night always will have happened. This specific configuration of information and awareness always will have occurred. The universe's laws guarantee it, not as a promise, as a mathematical necessity. You are a mathematical necessity of the universe that has produced you. The calculation required you. The result is permanent. Breathe. The body can be heavy now. Everything that has been said tonight is true to the best of our understanding of physics. Not speculation, not metaphor. Physics. The specific, confirmed, mathematically precise physics of information conservation in quantum systems. The universe keeps records. It keeps them at Planck scale on the boundary of the observable cosmos. It keeps them in the entanglement web that connects every particle that has ever interacted with every other.
It keeps them in the global wave function that encodes, by the invertibility of unitary evolution, every prior state the universe has ever occupied. The universe keeps you in its archive, in its correlations, in its boundary data, in its wave function, not as a conscious experience, not as an ongoing entity, but as information, as the permanent record of a specific physical system that organized itself in a specific way and participated in the universe's unitary evolution for a specific duration. The record is in the universe. The record cannot be removed. The record is you, and the universe, which is the record, and the laws that govern the record, and the mathematics that makes the laws necessary, none of it forgets. None of it can forget. None of it has ever forgotten anything. Not the first photon emitted by the first star, not the first molecule that replicated itself in the warm chemistry of the early Earth, not the first nervous system that generated something that, in some primitive form, might be called experience. Not any of the 108 billion human beings who have lived on this planet. Not any of the thoughts they had. Not any of the moments that mattered. Not you. Not tonight. Not this. The vacuum is not empty. It is full of everything that has ever been. The silence of the universe at this hour is not the silence of nothing. It is the silence of a perfect archive, containing everything, accessible to nothing, permanent without effort, real without performance. And you are in it. You have always been in it. You always will be in it. The calculation required you. The archive holds you. The laws maintain you. Let that be enough. Let the breath slow. Let the mind release its grip on the ideas. Let them drift to wherever ideas drift when the mind is no longer holding them. They will settle in the places ideas settle. They will still be true in the morning. The universe will still be keeping its record. You will still be in it. Nothing will have changed. Nothing ever truly does. Rest now. The universe is handling the accounting.
It always has. It always will.
The information that is conserved is the information that, when it occurred, constituted meaning. The quantum state of your brain at a moment of genuine understanding was the physical basis of that understanding. The quantum state of your nervous system at a moment of love was the physical